Kate, and I'm here to take you through one of my favorite activities called Pop Ecology Files. In this lesson, students graph 6 sets of population data and use clues to match completed graphs to the correct mystery species. Students will be able to create and analyze graphs of population changes over time, use evidence to support a claim identifying a mystery species, and compare human population growth patterns to those of other species. This lesson is for the middle school classroom, but it could certainly be adapted and used in a high school setting as well. The subjects are math, life science, environmental science, and earth science. To start, the lesson guides your students through the process of graphing the human population growth curve over time. Next, you provide students with a story that gives them some frameworks for the graphing they're about to do. The idea behind the story is that your student's aunt is a very well-renowned naturalist, and she has gathered data on 6 different species in the field. However, she lost the key, it happens to the best of us, and she is now unable to know which data set goes with which species. You have to help her figure out the mystery. So we provide students with a list of the 6 species that she studied, and a little bit of context about each of them. For example, for the cerulean warbler, it says, this tiny migratory forest bird may soon be added to the endangered species list, and it was studied in central Maryland over several years. To figure out the mystery, students have to divide and conquer. So split your class up into 6 different groups, and each group should have a worksheet with a data set on it. The worksheet guides students a little bit as they do the process of setting up and starting their graph. It asks them things like what they're putting on the y-axis, what's going on the x-axis, and how they should choose and fill in their scale. Once all the graphing is complete, students will need to decide which species matches with each data set and graph using their evidence. They can do a gallery walk to make sure they get a chance to see every single data set graphed before making their decisions. If anyone is stuck, here's a few hints that could help them out. One is looking at the scale and the length of time on the x-axis. Is it measured in years, hours, days? Another thing that could help is the total number of individuals in a species. For example, in some cases, we're looking at millions, whereas in other cases, we might only be looking at 10 or 20. Think about if there are any relationships between any of these graphs, and if there then might be relationships between some of the species involved. And finally, students should be looking at the trends overall in each graph, as well as patterns of growth and decline over time. So let's take a look at graph number 1. As you can see, this is a species without a ton of change over the years that it was studied. It's probably a fairly slow-growing species. This one best matches with the bristlecone pine tree based on its description. Moving on to data set 2, students will usually notice that there's a relationship between graph number 2 and graph number 6. When number 2 is high, 6 is low, and vice versa. Students will usually recognize that one of these must be the rabbit and one of these must be the red fox population. However, the more difficult part is deciding which one is the prey and which one is the predator. The trick is to look at the overall numbers on the y-axis. You're always going to have higher populations of your prey animal than of your predator animal in an ecosystem. So number 2 has to be the fox because its total population numbers are always lower than number 6, which is the rabbit. Taking a look at graph number 3, this one shows rapid exponential growth, and then it experiences a crash. This one matches with Bacteria X population 1, which was not given any new nutrients and completely used up its nutrients or resources before crashing. Number 4, we see a downward trend line, and we also see a zigzagging up and down over time. This one represents the cerulean warbler. It's going down over time, which is mentioned in the description as it being added to the endangered species list, and that zigzagging effect is actually due to its status as a migratory bird. Because it's in different places at different points in the year, their population is going to be much lower when they've already migrated away. And graph number 5 is Bacteria X again, but this time it's our second population. We see that rapid exponential growth, but then it levels off and plateaus as new nutrients were added to the test tube, so the bacteria were able to sustain that steady population over time. And number 6, we already went through as the rabbit, which has that predator-prey relationship with the fox. The discussion questions go a little bit more in depth into the life science aspects of this lesson. You can also connect any of these graphs back to the human population growth curve that students created at the beginning of the lesson. That was Pop Ecology Files. I hope you enjoyed it as much as I did. For more lessons like this one, go to www.populationeducation.org.